Hello, my name is a.c.atkinson.
And my name is Marco Riani.
In this video, we're going to talk about transformations of data. In one of our other videos, we talked about the box transformation and extensions, but these were all related to transformations of the response. In the generalized additive model, which we consider here, we have non-parametric transformations of the explanatory variables, which are found by smoothing, and we also have a transformation of the response, which is found by numerical integration of residuals to try to give a variance which is constant over the whole range of the explanatory variables. So this transformation then has a name which is similar to that of the Box-Cox transformation, but it's trying to achieve it without a parametric model.
As usual, all the code to reproduce the figures and tables in each chapter is inside the GitHub website of the book. We are in chapter 7. Now we go straight away to the analysis of the data. In the first example, we have a single explanatory variable, and then we have that the sequence from 0 to 15 with a step of 0.1 is transformed using sign, and then there is a sort of random noise. Some units have been contaminated. This is just to show you the scatter of X and Y. Let us see, you see the outline observations here. Now we start with the standard EVAs that we call without options, which is the basic implementation of Riani. So this is a 3-panel plot which summarizes the result from EVAs.
In the top left-hand plot, we have a plot of the transformed response against the response. In the upper right-hand plot, we have a plot of the fitted values along the bottom and the transformed response.
At the bottom, you have a plot of transformed X against X. You can see that the true transformation is sort of sinusoidal transformation. On the other end, the presence of outliers has distorted the correct transformation. Now we compare and we contrast this analysis with one which uses all our options. We will describe later what these options are. But now you can see that the correct transformation has been found.
There is what looks like a very regular sinusoid.
And then you can see marked in red the units that have been detected as outliers. Now the original data had been exponentiated, so now we have correctly recovered the true transformation. This is a simple example of the effect of outlying observation inside EVAs.
EVAs was introduced some time ago now by Riani, and the model that I described at the very beginning, he used his method, his numerical method, to estimate the parameters in that model. We have augmented this procedure by a number of options, perhaps the most important of which is the way in which the numerical calculations for transforming the residuals to homoscedasticity is performed. We call this option, because of its numerical structure, option trapezoid.
Yes, option trapezoid, like all the other options, can find a detailed description inside the ROSA website. Let us move to the second example. The second example is with two explanatory variables. Just to give you an idea about the Y against X,
it is almost impossible looking at this to have any idea whether there is any sort of structure underneath, although the sharpish bottom to the scatters might lead you to think that there is some model there.
Initially, we start with no option. This is the standard deep Riani implementation, and then you end up with the p-value of the Darwin-Watson test of the residual when no option is used, which is of the order 10 to the minus 21. Certainly there is a structure in the residuals, as can be seen from this plot. Also, the plot of transformer Y against fitted has a strange shape. Now we try to add just one of the options that we have included, option scale.
In general, the algorithm is very sensitive to various properties of the explanatory variables, particularly the order in which they enter the model. Option scale multiplies all the explanatory variables by their estimated regression coefficients from an ordinary least squares regression to on all the data, and this, which is only used in the initiation of the algorithm, provides a set of explanatory variables which have the same effect on the regression.
And if we use this option scale, the p-value of the Darwin-Watson test passes from 10 to the minus 21 to 10 to the minus 14. Still, actually, this says that there is some autocorrelation in the residuals, and then there are strange bands in the residuals.
Yes, this is what we have found over many years, that this is quite a feature of the algorithm when no options are used.
Now we use two options. An initial parametric transformation combined with option scale. And things are getting better.
This is the initial Box-Cox transformation of the response.
And still the residuals against fitted, you can see that now there is a sort of curved relationship, but much better than...
Yes, and the stripes have gone away.
Right. And now the p-value is still significant. Now we put all options, and then we find the results.
All options, of course, includes robustness, so we're able to detect outliers.
And the outlying observation have been marked in red. And now the p-value of the Darwin-Watson test is 0.43, which says that now lack of correlation among the residuals has been achieved. Now we move to another example, which is example 2. Now we contrast the previous analysis in which the options had been added in a manual way with an automatic procedure, which tries to find which options are relevant and automatically selects the combination of options which lead to a model in which the residuals are not correlated. The result of this automatic procedure is visualized through what we call an augmented star plot, which has a form of a star plot, and the array is present if that particular option is used.
Since there are 5 options, in all there are 32 possible star plots for the analysis of any set of data, but many of them are very small.
On the right, there is the heat map of the correlation matrix among the best solutions. The very high correlation coefficients between the first 2 solutions suggest that using or not option trapezoid in this example doesn't have a big effect.
Although the visual representation of the second option appears to be very much smaller than that of the first.
Because the Darwin-Watson test here is 0.32, on the other end in the first is 0.61. The size of this star is proportional to the p-value of this two tests, Darby-Watson test and Jark-Bera test. Now we contrast this analysis with the traditional one when all options are not used. You can see now the thing that we had mentioned before, that you end up with the structure of residuals which contains bands. The transformation of the explanatory variables is not doesn't seem to be smooth, especially for the first variable, and also see the effect of the outlying observation. Look now, the transformed y is completely affected by the presence of outlying observations. When on the other end all options are set to true, now you can see that the units that had been inserted as outliers have been correctly declared. There is one additional unit which is declared as outlier, but now you see that there is no band in the residuals. Now let us have a deeper look into this, the plot on the top left.
This really is a very strange looking plot, isn't it? It has virtually most of the observations lying on a straight line, and then a few of them almost on a horizontal line. In fact, this is a log transformation of quite a lot of very small observations, so they are causing this seeming vertical patch on the left-hand side.